So this is the December 17th public webinar on the subject of GeoPose and moving features. Welcome, everyone. I'd like to thank those who have taken the time to participate and encourage you to put your questions into chat and to save the discussions until after the presentation has been concluded. I'm sure there's going to be ample opportunity, and this is an intermediate point in the discussions between GeoPose and moving features, which I believe should be very rich and rewarding for everyone. Okay, Maxime, can you please share your screen with your slides and begin your presentation?
Yes, definitely. Hi, thank you
Hello.
for having me. If I share this, I assume you see my slides?
I do, and that's perfect. The way you are
Nice.
is just right. All right, thank you.
Okay, so let me get started. So to quickly introduce myself, Christine already did a bit of this. So my name is Maxime Schoemans. I'm at the moment a PhD student at the ULB, so in Brussels, finishing in a couple of months. And during the PhD, I've been working mainly on three projects, related projects. The first one being MobilityDB, so which is an open source moving object database built on top of Postgres. And this is also the main topic of today. And then the second project was Move, which is a plugin to visualize this moving object data from MobilityDB in QGIS. And the third one is MEST, which is related to indexing in Postgres and also related to indexing for MobilityDB. And I've been working on this supervised by two professors mainly, Mahmoud Sakr, which is also, I believe, well known in this OGC group. So he's a professor at the ULB and working both on the moving features API as well as the GeoPose standards. And Esteban Zimani, which is also working on the moving features API and the main primary maintainer and developer of MobilityDB. So before starting to explain how all of this is linked to the standards, let me start with a quick introduction on MobilityDB and then explain what in my project I was trying to add to this system and how this is then related to both moving features and then GeoPose. So MobilityDB is moving object database. So it extends Postgres and PostGIS with temporal types. So temporal and moving in this case are interchangeable. And these temporal types store the evolution over time of some base type. And currently, in the current version, MobilityDB has 6 base types for which it creates temporal types. And these are temporal integer, floats, text, booleans, but most importantly, geometry points and geography points. And so temporal geometry point can be used to store the evolution over time of the point that represents, for example, the position of a car or a ship or a plane. And how is this done in practice? So most of the time, this type of data arrives as sets of ID, an ID for the object itself, the moving object, and then pairs of timestamp and position being either latitude or longitude or XY, depending on if it's projected coordinates or not. And what MobilityDB does is that it combines all of the timestamp and position pairs for the single object into a single value, which is in this case called temporal geometry point, TGEOM point. And this single value represents the whole trajectory of this moving object. And so this simplifies the queries that can be made to the database, also improves the storage because it's more compact, and a few other interesting things. And so this type is already related to the first standard that we're going to talk about, which is moving features standards. Because in these moving feature standards, there are a set of classes or a set of types that are defined, which are used to store, as they call them, moving features. And there are two main types of moving features that they talk about in the standard. The first one here being temporal trajectory. And this temporal trajectory type or class can be used to represent the movement of a single point parameterized by a time parameter. And this is exactly what is being implemented in MobilityDB as this temporal geometry point type. So the movement of a single point, also called a trajectory. And standard defines a set of attributes, but also a set of functions that the type has to be able to answer. And in MobilityDB, we implement a set of functions that are equivalent to these standard functions. For example, value at timestamp can be used to repeat. Or where did you lose me?
You were talking about the benefits of MobilityDB, yeah, and this particular further down.
You were showing us the UML of MF temporal trajectory.
Yes, I was here.
That's it. Yes.
Mm-hmm.
Did I explain the slide already, or not yet?
You talked about trajectory, but not about temporal geometry. So.
Okay, yeah. So let me start over with this slide then. Yes, well, the standard itself describes this new class, temporal trajectory class, with a set of parameters or attributes and also a set of functions. And so what MobilityDB does is that it implements this class as a new data type in the database called temporal geometry point or TGM point. And so this type in MobilityDB is conformant to the specifications in the standard for this temporal trajectory class. And it stores, just as in the standard, the movement of a single point over time, parameterized by time. And in the standards, as you see, there are also a set of functions that the class has to be able to answer. And all of these functions, or most of them, are implemented in MobilityDB as functions that can be called through SQL. For example, the value at timestamp is equivalent to the point at time function from the standard. The at time is a function that can restrict the temporal geometry point to a specific time span. And this can be used to implement the sub-trajectory function of the standard, for example, and so on. Nearest approach distance is equivalent to nearest approach, and so on. So in this case, MobilityDB has this type, TGM point, which implements one of the classes from the moving feature standard. But this is not the only important class in the moving feature standards. The second one, which is the main important one in this case, is called rigid temporal geometry. And it is used to represent the movement or the motion of a rigid body. And what do we mean by a rigid body? It is a geometric object that can translate and rotate over time, but whose geometry does not change shape. So it's always the same fixed geometry, but we can move it through translation and rotation. And the main initial goal of my project when I started this PhD was to implement a new type in MobilityDB, which would be able to store or represent this type, this class from the moving features standard. And so how has this been done? So this has been done a few years ago already. And the main idea behind the representation or the storage for this type is that since we're storing a fixed shape object, and the only change is its position and orientation, there is no need to store the polygon or polyhedron multiple times. So we store this only once, and then the rest of the movement, the rest of the temporal geometry is stored as a set or an evolution of position and orientation. And in the case of MobilityDB, we made two implementations, which is hidden to the, no, not hidden to the user, which is the user can choose between either 2D or 3D. And so in 2D, the moving object is represented using a two-dimensional polygon. And then the set of position and orientations are represented using, well, 2D point and a single angle for the orientation or rotation. And the second implementation is in 3 dimensions, where the object itself is represented using a 3D polyhedron. And then the position is stored as 3D point, and orientation is stored as a unit quaternion. So in this case, there are, in the case of 3D, there are multiple ways of storing the orientation in 3D. The three main ones are angles, Euler angles, you have quaternions, and you have rotation matrices. And so in the context of a database, which is what we are working with, the rotation matrices have a bit too much parameters, so the storage would be too high. So we're using quaternions in this case. And the reason why we're using quaternions and not the Euler angles is because we also want an easy interpolation method, which is easier with the quaternions. And this interpolation is then used, for example, for the value at timestamp function that is also implemented for points, and we will re-implement for the moving or temporal geometries. And then next to this, so this defines the data model, and this is how we implement the data type in MobilityDB. And then next to that, we also implement a set of functions that can be used to analyze this data type. For example, linear interpolation is used, as I said, in the value at timestamp. We can also create compute the bounding box around a rigid temporal geometry. And this bounding box can be used for indexing purposes, for example. The traversed area is very interesting, is what you see here in blue, is the area traversed by this moving geometry over its movement. And so the result is a single polygon that can show you easily the shape traversed by this moving geometry, or temporal distance, which is also an interesting operation. And coming back to the standard, just as for the temporal trajectory, the rigid temporal geometry class asks for a set of functions to be implemented as well. And you see them here on the left. And so we implemented all of these functions in MobilityDB as well. For example, geometry at time is the equivalent to value at timestamp function in MobilityDB. The trajectory, which returns the movement of the center of rotation of this moving geometry, start time, timestamp, end timestamp, and so on. The only function that is not implemented from the standard is the intersection function, simply because, well, the intersection between a moving fixed shape moving region and another either fixed shape moving region or a fixed geometry is not necessarily fixed shape. And so the result cannot be stored in a type that is a fixed shape moving region. And since at the moment in MobilityDB, we don't have a type to store deforming moving regions or temporal regions, this function is not implementable. And I have here a set of visualization made using the Move plugin that I was talking about in the introduction, to show you examples of how this temporal geometry could be used for an analysis. For example, on the left, you see the difference between visualizing moving points and visualizing moving region. You can see quite clearly that the difference is noticeable. And here at the top left, you see an example of an interesting result from the traversed area operation, which clearly shows that the vessel was arriving, rotating, and going backwards into the docks, which is also something that is not visible just with the moving points. So now I believe you understand the link between my work, my implementation, and the moving features standard. But how is this linked to the GeoPose standard? So coming back to how we store this data type, I believe you might have already seen it a little bit. As I said, we store the geometry only a single time because it is non-deforming. So storing it multiple times would be redundant. And so in this case, the storage is as follows. We have on one side the reference geometry stored a single time with its rotation center around 0, 0, and facing to the positive x-axis. So the conceptual front of this geometry is to positive x. And so this is the reference geometry stored a single time. And as I said, next to this, we also have the evolution of the position and orientation of this object over time. And combining these two values together, we have a complete temporal geometry. And you see on the right, when we store the evolution of position and orientation, well, each individual value contains well, position and orientation and a specific timestamp which is associated to this. And well, the pair of position and orientation is called a pose, right? So essentially what we're storing here is the evolution of the pose of the object over time. And combining this with the reference geometry, we have all the information to store the moving geometry. And so in this case, we have a pose. So you could see how this is linked to GeoPose, but we'll come back to that a bit later. So what is implemented in MobilityDB is not only this temporal geometry type, which stores a representation of a rigid temporal geometry, but since we saw that internally, we essentially have a temporal pose as well, we decided to also add a new type, which is temporal pose without the reference geometry. So just a pose evolving over time. And to do this, of course, we need the base type itself, so the pose. So in MobilityDB, right now we implemented two pose types, one in 2 dimensions, one in 3 dimensions, which are storing the same parameters as we are using in the temporal geometry type. So we have position XY and then orientation theta in 2 dimensions. And in 3 dimensions, we have XYZ as position and then the unit quaternion for the angle. And then we also have, since this is essentially equivalent to what PostgresQL is doing for its geometries, we also store the SRID or the coordinate system associated to this pose. And then we implemented the type, which is called temporal pose, which can come in 3 durations. A pose instant, which is just a single pose associated to a timestamp. A pose sequence, which is a sequence of poses with a specific interpolation in between. So if it's discrete, it's essentially just a set of poses with their timestamps associated. And if it's continuous, it can either be stepwise or linearly interpolated between 2 poses. And this linear interpolation does essentially linear interpolation between the position and also this spherical linear interpolation between the orientations, which is an operation that can be done on the unit quaternions. And finally, we have also a sequence set duration, which is simply a set of continuously interpolated sequences with time gaps in between. And to link this to the GeoPose standard now, essentially the GeoPose standard defines what a GeoPose is, which is a pose which is geographically linked to. So it's a position on the sphere. I believe it is fixed to SRID 4326, although I'm not certain. And then at that position, we have both the position and also the orientation of an object. And in the GeoPose standard, there are a set of targets that are defined. And the first one, there are 2 basic targets, basic quaternion and basic Euler angles, or not exactly sure, the basic with the angles. And in this case, the basic quaternion is essentially what we store for each individual time step of our temporal pose. So as you see here, we have basic quaternion has 2 attributes, the position and the orientation as a quaternion. And this is exactly what I was mentioning before. Of course, this is for the case of 3D. In the case of 2D, we also have the same thing with single angle. This is not exactly defined in the GeoPose standard, but this is because I believe it's not in scope. And then there is an advanced target in the GeoPose standard, which is essentially combining a GeoPose basic quaternion with a timestamp. And so this is essentially equivalent to a temporal pose of instant duration in our case. And lastly, a third, well, there are more than that, but in this case, a third target is the irregular series, which is a time series of GeoPose values, each with an associated time. And so this, in this case, this represents temporal pose of sequence duration as implemented in MobilityDB. And there are some difference or some things that are not really, that are available in MobilityDB, which are not specified in the standard. For example, I don't think I've seen how to specify the interpolation if you wanted step linear discrete for this irregular series, although I might be mistaken. And one also other thing is how to handle temporal gaps. I'm assuming this might be multiple irregular series, but I don't think this is also specified. But you already see the link between the two, at least. And so just to summarize here, in MobilityDB, in my project, I added two new data types: temporal geometry, which is used to represent movement of a fixed shape moving region, and temporal pose, which essentially is a temporal geometry without its associated reference geometry. So it's simply the evolution of a pose or a position and orientation pairs. Both are implemented both in 2D and 3D. And well, the temporal geometry comes essentially from the moving features standards, and temporal pose is linked to the GeoPose standards, although they are, as you saw, very connected, both types. And due to the fact that they are so connected, we can easily go from one to the other, because simply discarding the reference geometry from the temporal geometry, we can cast it to a temporal pose. And we can also construct temporal geometries by associating temporal pose with a reference geometry. And then, as I said, we have a set of functions for both types that are being used in the standards, or at least in the case of temporal geometry. And yeah, so this is essentially the result, or what has been implemented finally in MobilityDB, or at least what is the goal as a final goal. So, as I said, this is the final goal, but currently part of it is implemented. Part of it is not in core MobilityDB yet. So just to explain a bit where we are in the state of the implementation and related to standards as well. All of this work initially was done in a feature branch of the MobilityDB code. So essentially it was kept on the side because we weren't sure if we were going to add this to the core. And recently we started adding little by little, starting with just the temporal pose, because this is the easiest to extend MobilityDB with. So currently in core, we already have static and temporal poses simply as input and output. There are not a lot of functions yet, but the type itself is already present. And then what is in a feature branch but has yet to be added to the latest version of MobilityDB are, well, the functions and operators for this temporal pose, as well as the temporal geometry type. And more related to the standards, both standards specify, so the moving features API as well as the OGC standard specifies some format to distribute this type of data in JSON. So I don't think either standard specifies a binary or text input output, but mainly JSON. And so this has yet to be implemented as well. Currently, there's only text input output. So yeah, this is the current state. I hope you see the link between the two standards and how they are really connected, because essentially we implemented the pose or temporal pose without even before knowing about the GeoPose standard. And when we heard about it, we were like, yes, of course, this is very related. So yeah, this is all I had. Please let me know if you have any questions about this, and I'd love to discuss.
Fantastic. Thank you, Maxime. And very good. Is as we agreed, what we suggested. And maybe could you please put this URL, or I can put that URL into the chat so that the people can easily go there. Are you going to do it, or do you want me to?
I can do it. I can do it.
Okay. Great. Thank you. So I think that we want to have the opportunity for people to study this further offline. We have just a few questions in the chat. Mikkel asks, you can see that it's 525. How do you
Yes,
solve the
yes.
issue with interpolations? I don't think you said it, but please answer the question. So we have that.
Yes, so essentially we always, in this case, well, the data arrives as a set of instance. And so we always assume that between two instances, the interpolation is going to go through the shortest path. So indeed, there are multiple, so there's a short arc and a long arc. We always assume the shortest one. So if this is not correct, possibly because two timestamps are too far apart, then either the user needs to add more timestamps or we need to create a gap there. But this is up to the user, of course. So in our case, we assume always shortest path between two angles.
Great,
Mikkel,
thank you.
Okay.
No, it's perfect. It's how to solve that issue is particularly complicated, and at the end of the day, just using the simplest solution is the best way.
Thank you. Yeah.
Thank you. Okay, there was
yes. In what CRS is the static geometry defined? Well, just like for the poses, the SRID can be specified. So it will be in the same coordinate system as the pose, since here we combine the pose with the reference geometry. So,
that's not exactly what I'm referring to,
no,
Maxime. So, you know, that GeoPose provides a position and orientation for a point.
Yes.
And then there's some geometry of the feature that the pose is applied to. And how those two relate is implementation dependent. Well, this is an implementation. So I wonder how you take, you know, this stored geometry and relate it to the GeoPose that you're providing.
Well, so this is linked to the assumption that we made here, I believe, if I understand correctly, that the front of the vessel is always towards positive x. So when we have an orientation of 0, or for example in 2 dimensions an angle of 0, this will be the orientation of the vessel.
So essentially you have, for this reference geometry, 3 points in the 3D case, in the general case. You have 3 points which are referenced to the axes of the GeoPose. So how do you do that in MobilityDB?
I'm not sure I understand the issue here. Could you clarify?
When you have a geometry, let's say you have a 3D geometry defined as a polyshell, and then you have a GeoPose which says, you know, this is the orientation for some point. So then there needs to be a correspondence between that GeoPose point and some part of the geometry. So you're showing here some concept of centroid, but of course that centroid would need to be defined. And you're also showing in the 2D case, a point being the front of the vessel aligned along the positive x-axis. So that's the second reference. In a 3D case, you need a third reference so that any application taking that reference geometry and a GeoPose knows how to reorient that geometry according to the GeoPose. So that's an implementation detail, but I presume that in the MobilityDB implementation, that information exists somewhere.
Yes, so indeed we ask when constructing the temporal geometry as a pair of temporal pose and reference geometry. The reference geometry has to be given based on these assumptions. So in 2D, we assume that the geometry is centered around its rotation center, around 0, 0, and faces towards positive x. In 3D, we have the same assumption of the rotation center. So we assume that the given polyhedron is centered around its rotation center, around 0, 0. And I believe it was the front towards positive x and the left positive y, and then up positive x. I'd have to check, but it's something like this.
So the reference geometry is actually being defined in the local GeoPose coordinate system.
Yes.
Which is great. But it's good to be explicit about that.
Okay, yeah, sure.
Okay, thanks, Josh. So Kim has asked, so she says the moving features JSON Prism assumes that a rigid geometry represents with the local engineer coordinate reference system. It transfers to the UTM system. Do you plan, Maxime, to support the Prism format in the MobilityDB work you're doing?
Wait, let me go back to the classes, because I believe, so the Prism geometry describes in all generality the movement of a geometry without fixing the shape of it. And then rigid temporal geometry fixes this shape. So in the case of the moving features, the main class was the rigid temporal geometry, and the Prism geometry is a bit more general, should also handle deforming, and this is something we're not sure of yet how to do, because it's going to be a different data format and so on.
Oh, in concept, you're implementing a prism with one leaf, the initial leaf.
Yes, essentially, yeah, it could be this. We're also thinking of implementing this Prism geometry, temporal, as without allowing linear interpolation, linear being loosely defined here, of course. But with just stepwise, this is something that we're thinking of adding to MobilityDB.
I have a question, Maxime.
Yes.
On behalf of GeoPose SWIG, did you find in your work or in your current work things that are missing or that you would like to see in future releases of GeoPose that would make your life easier or otherwise benefit your work?
Well, looking at the GeoPose, there are two things that are specified, which are targets and the JSON encoding. And I haven't yet tried implementing the JSON encoding, but it looks quite different to the JSON encoding of moving features. And so looking now at this in the sense of these are very similar, right? The moving features is temporal pose combined with a geometry. I'm wondering if there is a way to relate these two moving features, these two JSON encodings to one another. But I would have to go deeper into this. So I haven't. I've just looked at the specifications.
To reuse one part in one standard or reuse in another?
Potentially, yes, or at least make them more closely similar. So from what I remember, in the case of moving features, we have a set of date times, so a set of timestamps as stored as a list, also a set of positions, and then a set of orientations. So all three stored as a list. In the case of GeoPose, I believe it is the other way around. So we have a list, and then each element in the list contains both the position as well as the orientation, which of course makes sense since we're storing a list of poses. So this is quite different. I don't know if it makes sense to combine the two, but this is a thought.
To reduce the difference.
Yes.
Another question, did you in your work ever encounter situations where the readings are not 100% certain? Like there's some ambiguity in the reading and you need to express the uncertainty? I would think that that would be kind of important if you're moving a ship around a dock or something. You need to know what the certainty, Have you encountered any needs or requirements to express uncertainty?
In my case, not yet, no, because I assume I receive data. So I assume this data is correct. Of course, we see that it's not always the case, but we usually try to tackle that with data cleaning rather than storing the uncertainty. So I haven't looked into this, no.
Okay, thank you. Any other discussion or questions, topics? Floor is open. There's a chat. There's a question from Jake. Will the implementation be available in the MEOS library, allowing for use in other applications, not just MobilityDB? Since there
Yes.
was an example in QGIS.
Yes, indeed. Well, the example in QGIS currently doesn't use the MEOS library. We're working on modify or updating Move to use the MEOS library to make it more efficient. But indeed, when implementing something in MobilityDB, essentially we first implement it in MEOS and then create the bindings for MobilityDB or the wrapper on top of it. So currently what is already implemented for Pose, for example, is already in MEOS, except that it's simply hidden behind the compilation flag at the moment. But yes, it is in the library.
Thank you. Thank you. Jim Antonisi, I'm putting you on the spot. This is this intersection of the work of the moving features and geoposes of interest and concern to you. Have you any questions, or is this covering your questions already?
Yeah, this is useful. I just need to be clear about how these things are being resolved within the OGC is sort of one of the arenas in which we're looking at GeoPose, right? So so it's good to see this work implementing it. I think my questions are a little more, perhaps more elementary. I was a little confused about why this would be and this goes away from the GeoPose as such. I was a little confused about why you have to specify this as applying just to rigid bodies if we're talking about bodies represented as centroids. And maybe that's the issue, is that you don't quite have that. But if it's not a rigid body, you can still represent it by a centroid. And then, do all the same stuff and then ask in a different part of the conversation, oh, what's the trajectory of the arm or the wrist instead of the whole body? That I don't know if that, if that's something you've thought about, or if this is maybe not germane to what you're trying to
do. So I'm guessing here you're talking about these chains of objects or deforming objects, but defined using chains or links of other static ones?
Yes, that could be the case, but then for an object that has multiple moving parts, and not worrying about the really interesting case where the shape is deforming in some continuous way, but just an object that has maybe five parts where the relationship of the parts to each other is through a chain, you nonetheless have some place you're saying, well, this is the centroid, or this is where the object is in some sense, even though it's a deformable object or many parts object. Everything you're saying sounds like it would still apply, even though you were trying to define it just for a non-deformable object. Am I?
Yeah, no,
Yeah, if you
I believe
kept
you're
defining
right.
changes in that local coordinate system, then in each case it could be transformed back out to the geocentric coordinate system. But you'd always know where 0, 0 was. In fact, you'd know where the orientation was, because the shape would be defined in those axes which are being rotated by GeoPose.
Yeah, I think I see what you're saying. So you would combine temporal pose with another shape who might deform in its own local coordinate system. And then
it seems like everything you're doing would apply there still, if I'm understanding correctly. And Josh, I think you're saying that also, right? Is that true?
I'm trying to.
Yeah, good.
Yes, I think you're right. Yes, yes.
The second question I had is actually coming from a just straight computer graphics side, where you say you're not providing the intersection function, and I can see why you wouldn't, because things get complicated. But that intersection function is awfully important, and it's not looking for a function from a set of shapes to a new shape. It's looking for a function that defines a set of shape as input, and the output is true or false. Is there an intersection or not? That is awfully important in graphics. So you're turning away from that. Surprised me a little bit. Is it because because you're just focused on the shape intersections? Is that the issue?
Yes, well, in the standard, the intersection function returns another, I believe it was a prism, but so a temporal or a prism geometry. But indeed, if the result is a temporal Boolean saying is there an intersection or not, and then doing this over time, over the temporal duration of the moving geometry, this is indeed an interesting operation. But currently we haven't implemented it, but it is something that could be added. Yeah, it's a bit more complex to implement,
Yeah.
but indeed it is interesting.
I'd like to highlight that Kyung-Suk Kim has added some chat. One concern of integrating moving features in GeoPose is that moving features was designed for I think, to be complementary to GeoJSON, and GeoPose is quite different from GeoJSON. We've discussed the connections between GeoPose and GeoJSON, and there's Mikhail created a script that just converts directly one to the other. I believe that might be what's being suggested here. I don't know. Mikhail, did you looked at that?
Yeah, it can be done. It's just that GeoPose, from what I see, it is like an extension of GeoJSON that provides the ability to provide a rotation to a geopoint.
Yeah, I mean,
Only
you can
points.
always add the rotation as a property, but there's no semantics for it in GeoJSON. It's an
Exactly.
arbitrary property. Yeah.
Well, I have seen it, but not in GeoPoint. There is another way to define rotation, but it's not associated to a point. It's associated to an area or something. But yeah, in any case, it is something that it is complementary. And my idea will be to create something that makes it even more interoperable between them. And you have the code to convert from a GeoPose to a GeoJSON and vice versa.
You have the code in the sandbox. Yeah.
Yes, as well. Yeah. I will have to upload it.
One of the issues I believe is that the GeoPose doesn't treat areas. It has no knowledge of area.
We can define trajectories because in this case, it's interesting to have the rotation at different points or orientation at different points. But for the area, it doesn't make sense to use GeoPose because at the end of the day, we don't need the rotation for every single point in any case. So I truly believe we have to create something like a geopoint and a geo area and a geo boundary, if you prefer, just to store that semantic information in a way that it is compatible between all the different elements. Is what I have called before, like GeoPose and friends. But it is something that we have to discuss it further because then we are, instead of being complementary, we are re-implementing
Right.
GeoJSON. Overlapping, yeah.
Kyung-Suk Kim asked if you would please share the example of GeoPose with GeoJSON, and the moving feature SWIG can start some discussions on how to harmonize the two formats inside moving feature JSON formats. I can I can follow up with both of you on that. Josh, do you want to decode your quote there, or should we?
Yeah, I'm just saying that, and this is, Kim Suk understands this quite well, but there can be some misunderstanding of GeoJSON. GeoJSON, as any software is expected to be able to interpret it, is strictly CRS 84. And so what the RFC says is, yeah, you can go use another coordinate reference system such as a local one or UTM, but you can't expect that anybody who is not party to your extensional agreement will be able to interpret it. So when, strictly speaking, MFJSON, just like FGJSON, is not GeoJSON. It may be related to it, but don't feel that, for example, that it has to be within the context of GeoJSON, because as soon as you get off of CRS 84 in any way, you're leaving the interoperability represented by GeoJSON. So
Good
this is the result of
clarification.
many discussions. Is don't worry about it. Looks like GeoJSON, but don't feel that other means of harmonization have to be limited by that.
Thank you for that clarification. I think that's important for Jim also. Okay.
Thank you.
Well, yeah, we're up at the top of the hour, or almost to the top of the hour. I'd like to thank everybody for your attention and your participation in this discussion. I think if there is any, Maxime, do you want to put your email in the chat, perhaps? If there's
Yes, of
anybody who wants to
course.
follow up with you, and maybe there are other discussions, but I think that this is a good foundation, a place for us to begin, at least, getting a more active discussion between moving features and GeoPose, and making that life for implementers such as yourself a little bit less tricky, a little bit more clear for those who are publishing data sets or developing products in this area. All right, thank you, everybody. I will put this up. I'll try to find somebody to clip out the empty part in the middle, and then publish it up on YouTube.
Thank you very much for
Thank
inviting
you.
me.
My pleasure.
Thank
Bye
you all.
now.
Bye.
Hi, everyone.